All right, here's your practice one. This one's actually from 2009, guys, an actual FRQ that was on an AP exam. Okay, so we got this graph right here. It says let F, if you're good at scanning, this is like when you scan. Like you kind of like gather information, but you don't look too deeply into the information, okay? So let F be a twice differentiable function defined this on this interval. That's kind of weird, negative 1.2 and 3.2. With f of 1 equaling 2. Okay, so f of 1 equals 2. The graph of f prime, the derivative of f, is shown above. Now, I like to write and label it because I want to make sure I don't assume that that's a different function. Because there's so many times that I make that mistake. That's what I do. Okay, so you guys should probably do that too, unless you never make that mistake. Then we're at the graph of f prime crosses the x-axis at x equals negative 1 and x equals 3. I guess I just wanted to make sure that was clear that that's where the intercepts are. And has a horizontal tangent line at x equals 2. Okay, so I'll go ahead and draw that picture up there just so we know. I mean, it kind of looked like it was there, but they made sure that we know that it's there. Let g, look, a new function. Let g be the function given by this. G is e to the fx. All right, first question. Write an equation for a line tangent to the graph of g at x equals 1. Okay, so we had f prime, f, and g. This one's talking about g. Make sure you note that it's talking about g. And what I like to do first is to write the formula for a tangent line. So you have y minus y1, which is g of 1. Okay, and then you have the slope, which is g prime of 1, times x minus 1. I write this out to see, okay, what do I need in order to finish this equation? The first thing I need is g of 1. To find g of 1, I plug in 1. That's kind of weird. Like it's just a weird thing. Like we've never seen a function written like this with the function inside of it. All right, so what is that? What is f of 1? Do we know what f of 1 is? Is that given to us? Oh, shoot, it's given to us right here. Oh, yeah, that was kind of weird that they gave it to us right there. So it's just e to the second power. The next thing I need to find is g prime. So I can plug the 1 into it. So to find g prime, I look at my g and I think, all right, guys, what is the derivative of e to something? Yeah, it's e to something. Now, if that something is a function like we have right here, what are you supposed to do next? Multiply it by the derivative of that something, which is known as the chain rule. Good job. Okay, so now let's plug in the 1. When I plug in the 1 to see what I got here, I get, I still have e to the second power. And then how am I going to figure that out? What is f prime of 1? Is there anything that says that, what that is right here? Oh, shoot, the graph is right here. F prime's right. Do we know what we get when we plug in 1? Oh, I was wondering why they labeled that random point right there. And so that's negative 4. That simplifies to look like this. Negative 4 times e to the second power. So I plug those into my tangent line, and you can be done right there. I actually don't like to leave my tangent lines like this. I like to get the y alone. But that's just me. You don't have to do this. But that's where I would leave my answer. All right, so for letter B, we're in this interval. It says find all the values of x for which g has a local maximum. Justify your answer. Now, guys, whenever it says justify, that means it's not requiring words from you. Can you use words? Yes. But justify can most of the time be done with math work. So make sure your math work is very clear. Do you guys remember how to find critical values and do a sign line graph? That's how we can find local mins and maxes, and so that's what I'm going to do. We need to set g prime equal to 0. Why? Because that's how we get our critical values. So what does g prime look like? G prime is e to the fx times f prime of x. This is something we figured out in letter A. I'm setting it equal to 0, and you guys can easily do this one. It's a weird one, though. Do you guys know why you can easily do this? Because you've done it before. Do you guys remember the zero product property? It looks like this. You guys remember when you got two numbers and they multiplied together to give you a 0? And you would take each of those factors, set them equal to 0 and solve? That's what we got going on here. We have two numbers. We have e to the fx and f prime of x multiplying to give you 0. So you take each of those, set them equal to 0 to see if you can solve them. So we take a look at the first one. And I don't know if you guys know this, but do you guys know how this graph looks? How e to something looks? It's exponential, right? Is this ever 0? No. So this will never equal 0, so that one's out. Now we look at the other one. Where is f prime of x equals 0? For this, we're going to need the graph again. So we go above and look at our information that they give us. Do we know where f prime of x equals 0? Yes. It says it on the graph, and they told us in the directions. So we know that when x equals -1 and 3, or 3, f prime is 0. So those are two critical values. And so now I'm going to do a sine line graph. Now, guys, keep this in mind. Remember, sine line graphs do not count for justification. Remember what I said earlier, how justifying usually is just math work? They don't want you to give them a sine line graph, okay? Now, the way I do my sine line graphs is I label them. I label this x-axis. But I think what they've found is that a lot of people don't know what the heck they're doing when they do a sine line graph. And so we need to make sure we're really explicit with the sine line graph. And so what you do next is you pick numbers in those intervals to test. And so now I'm going to try the -2. I'm going to plug -2 into my G prime. I don't know why I didn't label that properly. Here, let's go. So this is G prime right here. And then, oh, shoot. There's an issue here. -2 is not in this interval right here, right? Where does the lowest x go to? It goes to -1.2. So I changed the -2 to -1.2. So now I got to change all these -2s here, which actually makes it a lot easier. Okay, now e to anything is going to be positive. So I didn't even change that -2 to be -1.2, but I can. Here, let me change it really quick. That's 1.2, -1.2. But it doesn't matter because e to anything is positive. And then f prime of -1.2, when I look at that, is that positive or negative? Is it above the x-axis or below the x-axis? It's above. So I put a plus sign. Guys, what is plus times plus going to give us? That's going to give us a plus. So I know this interval is positive. Now we go to this interval. We try 0. I plug in 0. This is what I get. I know that this one's going to be positive. E to anything is going to be positive, right? And then for the other one, I have to plug 0 into f prime. If I go to 0 right here on f prime, is that going to be a positive or negative number? Negative, because we're below the x-axis, and so that's negative. So we get a negative right there, a negative number. So this interval is negative. Now I'm going to test 4. Wait, I can't test 4. So let's test 3.1 or 3.2. That's fine. So I plug that in. The e to the whatever is automatically positive. I plug in 3.2. I look at 3.2 right here. Are we positive or negative? Positive. We're above the x-axis, and so we have a positive times a positive, which is a positive, so I know this interval is positive. So we're looking for the local maximum. Where's my local max? Is it at -1 or 3? Is that -1? Why? That's the question you got to answer. Why? How do we know -1 is where the local maximum is? Oh, don't say the word it, please. That's a bad word in calculus. Why? Okay, there's two ways to describe it, guys, and you have to be very specific here. Do not say it, okay? So I'm going to make my statement here. Local max is at x equals -1. Why? Because x prime is greater than 0, then x prime is less than 0. All I said was that we go plus minus. That's all I said right there. But I'm very specific as to what that plus means. What's the other way to say it? The other way is to say it is saying G is increasing, then decreasing. Notice though, it's G. It's not G prime. This means that G is increasing, and this means that G is decreasing. Okay? Now, both of these are correct, but I like the top one. I think that one's better. It's more direct. It's directly related to my sine line graph. So I think this is a better answer, but I know for a fact that you guys would get credit for this one as well. All right, letter C says the second derivative of G is this. Hey, they give us the second derivative of G. Great. Is G double prime positive at -1? Is it positive, negative, or 0? That seems like a weird question to me. And so I just start writing it out, and then I start figuring out, oh, that's what they want to know if I know. So I put the graph down here. I'm going to write it out right here. I'm just plugging in the -1, and I'm going to try to see if I can know the signs of everything here. Now, the first part's easy. That's positive, right? Z, right? This is always positive right here?
Yeah.
Okay. E to something is always positive. So now we have the question of the stuff inside. Okay, now I'm taking you guys through a thought process. This is not actually the best way to do it, but anything squared. What is anything squared going to be? Positive. So I'm thinking, okay, that one's positive. And then F double prime of -1. Do you guys know what F double prime means in relationship to our information over here? Yes, it's concavity of F, or it's the slope of F prime. All right, so look at the point right here. We know that F double prime is negative because the slope is negative right there. At x equals -1, F double prime is negative. Is everybody cool? You guys got that?
Yeah.
Okay. That is a big calculus concept that you need to make sure your scorer knows that you know. Okay, so now my question is, all right, so inside here, which number is bigger? Is the positive number bigger or the negative number bigger? Because that will change what we're multiplying to the x or to the positive number right here, right? So this is where I went back because I was like, well, how do I know how positive this is? I looked back at f prime of 1, and guys, what is f prime of 1? It's 0. So like, shoot, that's not even a positive. That's just a 0. So that's a 0, and 0 plus a negative number. What's that going to be? Oh, that's going to be a negative number. So we have a positive times a negative, and so we know we got a negative number, and that's our answer, right? We answered it. It says, is it positive, negative, or 0? Now, you could probably leave it like this and trust your scorer. Is your scorer going to recognize that you know that f double prime is negative? I don't know, but I want to make sure they know. So I'm going to write that. I'm going to write that f prime of -1 is 0 and f double prime is less than 0. Do you have to write that? No, it's kind of extra, but I want to make sure they can read my stuff because those are the calculus concepts in there. And so that's your answer for that one. All right, pay attention to detail, Stews. Check this one out. It says, find the average rate of change of G prime. The derivative of G. Oh, well, duh. I know that G is the derivative. Whatever. Over this interval. Hold on. Guys, where's the vocabulary term here? Do you guys see it? Average rate of change. Guys, what is that? Now, I don't know about you, but when I see the word average, I think of two things. Do you guys think of two things? I think of average rate of change, and there's average value. You guys remember average value? Average value, you use the integral. You sum all the y values, then divide it by the interval. Average rate of change is algebra's slope. That is the slope of the secant line. Do you guys remember that stuff?
Yes.
All the way from the beginning of the semester. So this is all we're doing. We're finding y minus y over x minus x. Okay? Now I know some of you guys thought average value, but this is average rate of change. Guys, what is the rate of G prime? Come on, tell me. What's the rate of G prime? You guys don't know? Oh, we're all screwed. No. The rate. It's G prime prime.
I was thinking that.
G double prime. You were not thinking that, you liar. Okay. So, if you guys want now, G prime prime, that can be a value, but those are also known as rate numbers for G prime. So you could write it like this.
What the hell? No.
These are the same, aren't they?
No.
You guys don't think those are the same?
No, they are.
Do you guys know what the antiderivative of G prime prime is? It's just G prime, right?
Yes.
And then we have to plug in the 3 and the 1. Check this out. You plug in the 3 minus, you plug in the 1, and then you multiply it times this fraction. It's the same thing. Do you guys see that? This is the same as this. These are the same. Okay, so let's finish this. So I got to get this all my information from the beginning because I'm thinking, what the heck is G prime? What is G prime of 3? So I plug in the 3 into this, and think about it for a second. Oh, man. Do I know what f of 3 is? Does it tell me what f of 3 is down here? Shoot, it doesn't. So let's just finish this line here. Do you guys know what f prime of 3 is? Ooh, that's awesome. That's why we don't need to know. Because what's anything times 0? 0. So that's 0. Do we know what g prime of 1 is? So we plug that. Did we do that earlier? I don't know. Let's see. What is f of 1? Do we know that? Oh yeah, they tell us right here. F of 1 is 2. So that's e to the 2. And what is f prime of 1? Oh yeah, we did that before. You guys remember that? So we write that out really simply. And then I plug everything back into my original average rate of change. And then make sure you write your stuff out. Otherwise, you'll lose negatives. Our answer is 2 e to the second power. And that's all we had to do.